Welcome to the Exactpro Systems YouTube channel. Here you can catch up on the latest technology updates in software testing and development for the financial industry. These include the applications of AI and machine learning, DLT, cloud computing, and many other technologies and solutions. You can find the recordings of our latest conferences featuring top-level speakers from global market infrastructures, world's leading banks, and technology vendors. You can watch the Exactpro experts sharing their insights with the fintech community at events all around the world and with our subscribers in the regular Exactpro Talks segment. If you're interested in the Exactpro test tools released to open source, you'll find a list of tutorials here as well. We also put a new spin on some of the popular shows that we bet you've never thought were about software testing. This channel is for chief technology, information and compliance professionals, product owners, and software quality assurance and development specialists of all levels. Subscribe to our channel, hit the bell button to stay up to date on all the videos, and visit our website exactpro.com if you want to learn more about us.
Hello everyone, and welcome to the demo stream. I hope you have a nice day and fix EMEA conference. My name is Joseph Witkin. I'm CEO and co-founder of Exactpro. I am also co-chair of MOST working group in fixed trading community. MOST stands for Monitoring, Onboarding, and Software Testing. We focus on mission-critical software used in exchanges, brokers, clearinghouses, and other members of fixed trading community and trading industry. Today, we are very happy to present you our next generation software testing platform, TH2. And without further ado, we'll proceed with the demo.
To properly address the challenges of modern financial technology systems, one should have a scalable and resilient way to model, generate, execute, and interpret arbitrarily many diverse tests and their permutations against any number of environment configurations, as well as to simulate, observe, and collect traffic and events from various endpoints and store them for human and machine analysis. In order to achieve all this, we've created a microservices architecture where the system consists of many independent modules responsible for different tasks. They are connected to each other to perform various test activities. Here's the configuration of the test harness. The purpose of some of the modules is to connect to the interfaces of the system under test. Here you can see several client and server fixed connections and log extractors. TH2 supports dozens of APIs and protocols and is integrated with UI test automation frameworks such as Selenium and WinApp. The setup also contains the components for encoding and decoding messages. These include the components to be used in the script for sending orders and receiving responses, the components for monitoring the incoming messages, checking their content and consistency, and finally a programmable emulator of the trading venue and the test scenarios. All these components and their connections are configured here and can be reconfigured and updated anytime without significant disruption of test execution. Now let's see what the active tests may look like. These tests can be written in modern mainstream programming languages and driven by industry standard frameworks such as JUnit, Cucumber, PyTest, and many more. Python, Java, and Kotlin are used in this demo. This is an example of a simple script that generates orders, trades, and order management transactions in the trading venue. Here on the screen, we have an example of a fixed order entry scenario. By using the placeOrderFix method, we are calling ACT to form and send a single order message to codec and then to the corresponding connection. This method also shows the results of this action and displays the corresponding response from the system. Check sequence rule will validate the content and the order of the messages received as a response from the system. It will call the check component, which is working in an asynchronous mode. In case something is wrong, it will indicate inconsistency in the results. Let's execute the test and see the results. All activity in TH2 generates two types of data: events and messages. Events are structured logs of what happened in all TH2 modules, and messages are a collection of all raw data consumed or generated by the system under test. In our case, we will have all the details of fixed messages processed by all connections. In the TH2 UI, we can investigate events messages and link them together. The script generates a root event corresponding to the execution, which will contain all the related actions. As you can see here, the placeOrderFix method calls ACT, sends a new order, and waits for an immediate response. And check sequence row verifies the response content and shows a comparison table with the past actions and messages tab. In case of failure, we will get a corresponding error. Apart from these straightforward tests, we need more complex features. One of the examples is reactive modules, which react to the messages received by TH2. In our demo, we use the simulator component. This component simulates the responses from the system. The behavior is defined by specific rules written as a Kotlin script. For this example, it sends back execution report, reject, or business message reject, depending on the incoming new order single message. It reacts to the message received from the system under test and generates a corresponding answer. We can see how the simulator works by looking at the messages in the TH2 UI. In order to verify chaotic system behavior under load, it's highly efficient to verify as many things as possible in passive tests. This means verifying incoming messages for content and consistency without any knowledge of what caused these messages. It's what we call testing by monitoring. Let's see the recon module of TH2. The recon module is used to check the data independently from the usual execution. It can validate different message flows using specific rules written in Python. Here we have a rule that checks the consistency of execution reports after the trade between participants. All data from the corresponding connections will go through recon, and as a result, this component will provide us with a report. This report will contain matched, unmatched, and failed events that were captured during the executions. When we run many tests in parallel under load, it's impossible to make conclusions about test results manually. To address this task, TH2 offers data services providing access to structured test data for modern data analysis frameworks. In this example, we're using Jupyter Notebooks to retrieve data about the tests, analyze the data, and collect meaningful statistics about test execution. Here, as an example, we can build stats from different TH2 events or stats based on different message types and their contents, that is, order types, execution types, and other tags from execution reports, or the stats of the events generated during the execution, as well as measurement graphs for the corresponding check and recon events. That's it for our demo. We'd like to thank the Fix trading community for the opportunity to hold this session, and we thank all of you for your attention. We're happy to answer your questions at the virtual Exactpro booth right now, as well as during the rest of the day. Thank you.
Thank you. Thank you very much, Daria, for preparing the demo and sharing it with us today. Let's check if they have any questions in YouTube.
Sure. So I'm going to be looking at the live chat right now, and if you do have questions, feel free to ask them. So question number 1 is reconciliation component. In your example, the recon component operates with fixed messages. How about different data types, for example, REST API messages?
Good question. So the idea of TH2 and our multi-protocol testing is that the platform enables normalized testing activity across variety of protocols. So the very same things that we can do for fix, we can replicate for other protocols, capturing, processing, storing, and applying reconciliation checks, including validating our interactions with the front ends and the backends over REST APIs.
All right, thank you. The next one up is, what versions of the fixed protocol do you support? Can I use SBE?
Okay, sure. So we work with many different exchanges and other trading platforms. We have active projects supporting fixed versions from 4.2 to 5.0 SP2, and we are looking to fix latest. So it is possible to use the framework for different versions of fixed protocol. You just need to configure the dictionary files to reflect it in QuickFixJ or Fix Orchestra format. As for SBE, yes, we do have a set of projects relying on simple binary encoding, and the platform also supports it.
All right, thanks, Yosif. I believe we have a couple more minutes, so we'll take a few more questions. The next one up is it possible to run checks on the production captures?
Mm. Well, so TH2 natively supports passive testing components that can extract information from a variety of systems, from test environments, from production environments. We do have read components that can extract log files through integration with various log extracting systems or pickup files. So yes, it is possible to take captures from production system and put it through TH2 infrastructure into the Cassandra database for consequent analysis using various data services tools.
All right, thank you. So the next one would be, for statistics analysis, is there a feature to compare statistics gathered from 2 different runs? That's a good one.
Sure, it is necessary to configure it in data services. So Cassandra database will contain the output for both test runs, but it is necessary to use queries to compare the data, and we implemented in a custom notebooks, for example, in Jupyter, to perform such activities. It is also possible to integrate it with other reporting solutions.
Okay, thank you. We also have a question referring to the demo itself. Alex is asking, what do you mean by saying without significant disruption to test execution?
It is a good question. So the idea of Teach2 is to run high volumes of automated tests, uh, hundreds of thousands, millions of tests, and we need to make sure that the test system, test environment itself is stable. Even though particular components might go down, there can be multiple instances of the system under test, etc. So when something is replaced, we expect that there will be only local disruption for particular execution paths. But overall, the test system and data collected will remain intact, and we expect that the changes in the test tools should take uh, minutes to be deployed, and and everything is restored to normal, and we can proceed with massive test execution in that particular local area. In other areas, we expect that even when there is a restart, the rest of the system continues to operate properly.
All right, thank you. I think that already answers the next two questions. So I'm going to skip them and move on to one more that refers to non-functional testing, I believe. It says latency reports. How easy is it to calculate and generate the respective graphs and results?
Good question. Good performance testing reports and latency charts is at the confluence of science and art, so they to be relevant and to be uh, how to say it better, to be useful for other humans. It is necessary to invest some time to design the performance testing report. We have integration between Teach2 and number of reporting systems for most of our non-functional testing activities. We are using uh, Grafana to present information, and we extract data from Teach2 into Grafana for analytical and monitoring purposes.
All right. Probably the last question we're going to talk about is about TH2 itself. How long does it take on average for a QA engineer to adapt to working with TH2?
All people are different. Diversity is our strength. So different people take different time to learn any tool and any technology, and Teach2 is not an exception. I think it usually takes a few weeks before one can better understand the technology stack, Kubernetes, GitLab, Fix, etc. But after several weeks, a reasonably good software tester can proceed with designing, executing, and interpreting more and more tests.
Thank you, Iosif. I think we are done with the questions, and I believe we are way over time. So do you want to wrap up the session?
Yes, thank you very much, Daria. Thank you very much, everyone, for joining today's session. Hope to see you soon. Please do subscribe to our YouTube channel and have a nice day at Fix EMEA conference. Thank you.
Thank you.